So today's topic is are predefined agents really the answer? And how can we build accurate task specific agents on the fly? Um, but before we go about answering that specific question, let's first think about AI itself, right? Um, I asked you, right? Do you trust AI for business critical tasks? And this trust is established when AI feels reliable. How do you trust humans, right? You trust humans when you feel that they are reliable. They're accurate in what they're saying. They're transparent in how they work. They can do the same task repeatably with the same level of accuracy. You can work with them. You can collaborate with them. You can steer them and guide them to the right answer, and then you trust them with safety and security, right? So these five pillars of trust not just apply to humans but also applies to AI, right? And um, and this is what is hard to build. Anything which claims it's 100% in the AI landscape should be taken with a grain of salt, and we are trying to claim that. But at least we understand these are the five principles that we need to focus on to build highly reliable AI. But why is it hard to deliver such AI, right, on enterprise data? It's hard because you need to connect your AI to multiple different types of data sources, right? And the way you should be thinking about is listening to your colleagues, your leadership, your employees in the company, and see if they're talking about that AI is not really ready to answer questions on their data. AI isn't able to connect the dots about your data landscape. AI is struggling to integrate with different data sources and stuff like that. Um, then the second problem is that AI fails on answering complex questions or tasks, right? Like I'm not going to ask a simple question like how many R's are in strawberry, which also AI fails on. But uh, I need to get complex tasks done. And can AI really help me with that? Like which are like 5-step, 10-step tasks, which would typically take me a week to complete, but can I use AI to just get done within in a matter of minutes? Um, these tasks can involve complicated compute, complicated math, data analysis, cross-domain joins, stuff like that. Um, then give a free-form text box to a user, right? They will ask whatever they want. And unless you have systems under the hood, you will not be able to answer those questions, right? If you don't have that specific system under the hood, your AI will not be either, it will just completely hallucinate, or it will outrightly tell you that I can't answer that question. And finally, securing your AI is really hard. That your AI should not have any data leakage. AI should not be able to access any data that you as the user are not supposed to access to, right? So, and you have to handle all of the company's data with high precision security. And these pains translate to each different level in the company. So from the business leader to the technology leader to the practitioner, the engineers and AI engineers or data scientists, and then finally the AI consumer in the company, right? And these pains trickle down to each level. The business leader cares about that. Hey, if I'm investing a significant chunk of money in AI, am I getting a clear ROI? The technology leader cares about, is it actually solving the problem? Will it scale well? Will there be adoption inside the company or not? Will it be trustworthy or not? The AI practitioner, the software engineer, the data engineer, they think about, okay, how do I build such an AI system? Right? What kind of tools do I use? Are they easy to use? Are they maintainable? And then finally, the AI consumer, they want to know whether I can consume an AI in my day-to-day work. Does it help me with my day-to-day work? Do I really understand what it is doing under the hood? Is it a black box or not? Can I trust it or not? Um, and that is not the case today. Let's look at one example of an enterprise grade AI, right? Which is Einstein on Salesforce. And if you ask a question like, can you calculate our average sales cycle length? I tried it once on our Salesforce instance, and it says you have to do it yourself. Here's are the steps of how to do it. So I refreshed the instance and asked it again. Can you calculate the average length of our sales cycle? This time it says 71.6 days. And when I asked it, how did you calculate this? It said that I took average of stage 1 to stage 4 age length field. But we have 7 stages. So can you try again? But it did not continue responding. So refresh the page again, try it again. This time it says 2.21 days. So different answer, but the same approach. So completely inaccurate, completely non-repeatable, right? But before the age of AI, right? If you think about how humans used to operate, if I were to ask this question, if let's say your business leader, let's say your COO or head of sales wants to ask this question, they'll ask their data analyst this question, right? And the data analyst will go to the database. So let's say it's coming from Salesforce, so they'll go to the Salesforce, write the right queries to pull the right data. Then they might need to do some kind of compute or math or whatever they need to do to process that data. Either it is in an Excel sheet or is it in code, but they will do some kind of data processing. And then finally shares a report back with the business leader, right? Either a PDF report or a CSV file or something like that. So that's how humans operate. But if I ask you as a human, here are a few numbers, tell me how many numbers are there. Can you sum up these numbers and give me an average? And I did this. I asked a friend, and they are no longer friends. But I gave them 10,000 numbers. It was just a short list of those numbers. And I asked them, as I tell you these numbers one by one, can you start counting them? Can you tell me the sum of these numbers? And can you tell me the average of these numbers? They could not answer the question, right? But then I said, okay, but this looks like a Python array, right? So I'll give you these numbers as a JSON, and then can you answer these questions? And then the person was like, yeah, I can literally write one line of Python code and I'll give you the answer. Like, perfect. So you understand that humans cannot really handle data in their own head. They need access to tools, right? To really uh, get to the right answer, especially when it comes to large amount of enterprise data or different types of data, structured data, unstructured data. So I thought, let me do the same experiment, but with AI, right? So I took an LLM, GPT-4o, and gave it these 10,000 numbers. It says that for demonstration purposes, let's take the first 10 numbers to process. I'm like, okay. It did its math, right? It wrote its Python code, gave me an answer, but in its natural language response, finally, it said the count of numbers is 50, and the sum of all numbers is this, and the average is this. How? I don't understand. You literally just did the math. Even for 10 numbers, you did the math right, but your natural language response was wrong. So how does that even work? So I thought, okay, low stakes, smaller model. Let's use a fancier model. So I moved on to O3 Mini High, and O3 Mini High thought for 9 seconds. I was like, okay, the user has given a long list of numbers. This might be huge, perhaps even 1,000 numbers, 10,000, but okay. Since Python is available, I can use it to compute the values. Okay, it's smart. So it tries to start printing these numbers into its Python program. Now there are 10,000 numbers. If it tries to repeat those 10,000 numbers in its Python program, there's no way it's going to get all of them right. Either it'll miss some of them, it will get them incorrectly, or will completely hang. And that's what happened. It kept writing for a few minutes, and then finally analysis paused and did not even come back with a response. So I thought, okay, a different AI could be better than that, came after that. So I looked at 3.7 Sonnet with extended thinking. Now, 3.7 Sonnet with extended thinking is really good at writing code. It writes a lot of code, can handle massive amount of context. So I gave it 10,000 numbers, and it thought for 5 minutes, 4 seconds. For 5 minutes, it second guessed its entire life. It first started summing up these numbers one by one, and then realized it will take too much time. So let me start with a different. Let me use a different approach. Let me do some kind of approximation. But then second guesses itself again, saying, "Oh no, the user has actually asked me to give an accurate answer. So let me go one by one." Then continues to 1,000 numbers, then stops and says, "No, it's going to take a lot of time." So then finally it says, I've been counting systematically in blocks of 100, and I've determined that there are approximately 5,000 to 5,600 numbers in the array. Okay, systematically and approximately should not be in the same sentence, but okay. And then finally says that approximately 5,000 to 5,600 numbers cannot accurately calculate the sum, cannot calculate the average. And then its natural language response, finally, it says there are 4,800 numbers in the array. How? Your final response was 5,000 numbers. And then somehow you have the sum, somehow you have the average. But now, see, it can't handle the data. So that's what I'm trying to say, which is we should think about LLMs just how we think about humans. Humans need to be equipped with tools to get work done. Similarly, LLMs need to be equipped with tools to get work done. LLMs should not be directly given any data in their own LLM context. Because if they are given the data, they will not answer. They will not be accurate. It's a different story for unstructured data because LLMs have to understand and look at unstructured data. But when it especially comes to structured data, SQL databases, NoSQL databases, APIs, SaaS applications, we should not be handing the data directly to the LLMs. And that is the problem, which is in context data retrieval and processing. And that's what all the different approaches that we are trying to build today are, right? And then let's take it to the next step. How do you communicate with your colleagues? Do you say everything out loud, or do you share like files and write code? Let's say the data analyst, the business leader asked, hey, can you give me a report of the 10,000 most active customers that we have? Will the data analyst say the names of every 10,000 customer one by one in a meeting, which will last for 7 hours? No, right? They will share a file. They'll share a CSV file or maybe a piece of code which they can execute or XYZ. So that's how you communicate, right, as humans. So why do we expect the LLMs to communicate in natural language? And we just proved that LLMs cannot handle data in their own head, just like humans can't handle data in their own head. So now when it comes to communication of LLMs, why do we use natural language, right? Because when we have for these multi-agent kind of architectures, right, where you have a orchestrator agent and then you have a bunch of sub-agents which are designed for specific tasks. This orchestrator agent is talking to these sub-agents in natural language. They're responding back in natural language. And finally, the orchestrator agent also responds in natural language. And all of the data is moving through these different agents through their head, through their context, through natural language. And that is a very lossy process, right? And that is where they can't really handle data. What if I need to do a cross-domain join? And I need to use two different sub-agents to do this kind of a join. And how do I send thousands of rows of data from one agent to the other in natural language, right? I can't. So why do we build multi-agent architectures any differently how we think about how humans communicate? And that will be the recurring problem with all kinds of in-context methods out there, right? Even if you do tool calling, even if you do text to SQL, these are great. Like these are great for making one specific task or one specific agent work well. But as soon as you start building an enterprise AI system where you stitch together these different agents, all of that starts happening in natural language. So all the determinism of these underlying tools goes away. And the thing, and as we realize, right, that the LLMs are not good at processing like this large amount of data in context. So imagine an AI system trying to answer a question like this, right? Some of you who have attended our past community calls must have seen this, that find tickets raised over the last 7 days by enterprise customers. Think of like an internal customer support kind of use case. So a customer support specialist wants to know that who are my enterprise customers who have raised support tickets in the last 7 days, and that support tickets are about service timeouts, and where we are also missing out on their SLA. So can we understand whether these tickets were resolved or not? And if they were not satisfactorily resolved, can we issue $100 in credits to them? And this is a difficult task, right? Because multiple data sources, structured queries, unstructured queries, calculations, summarizations, and then actions. So a bunch of different things are happening. Now, if I have task-specific agents under the hood, right? One agent which fetches tickets, one agent which fetches the customer details, one agent which does, I don't know, SLA calculation, one agent that issues refund. How do these agents orchestrate with each other? I might have hundreds of enterprise customers, right, who fit into this criteria. I might have thousands of support tickets. How do my agents transfer this information from between each other and ensure that there is no loss of information, there are no hallucinations, there's nothing? And that's what is hard. And even if a single agent, just with tools, which might have like a multi-step question asked to it, even a single agent with tools does not work. And we tested it out. We tested out with Claude, O1, and O3 Mini with tool calling, and we connected these different database tools and Python tools and stuff like that to the LLM and asked it these kinds of questions, and they completely failed. Like the average accuracy was below 50% for Claude and less than 60% for OpenAI, and so we realized that just like humans, LLMs are good at planning. So instead of asking them to actually answer this kind of a question, if I would have asked the LLM, hey, can you just tell me how would you approach this problem? Do not actually answer my question, just tell me your steps, right? So LLMs will give you a very good answer. They are good at planning, and same like just like humans, right? Like humans cannot really read the entire database, keep it in their head, and then answer the question, right? No, but they can. They're really good at planning, where they can come up with, okay, to answer this question, first I need to fetch data from this database, and then I need to write some kind of these kind of data composition queries. I need to call these two other LLMs to do kind of summarization tasks and stuff like that. So I can create this query plan, right? So LLMs are really good at that as well. So that's what we should be doing, which is decoupling plan generation and plan execution, right? Let the LLMs come up with how to approach a problem, but do not let the LLMs execute that problem. So coming back to this multi-agent kind of architecture, right? So what we are saying is that let them do the planning, let them not do the execution. So I can put this philosophy in every single sub-agent. But now, will I have very task-specific sub-agents? Because as I said, right, one agent that fetches support tickets, one agent that fetches customer information, one agent that issues refund. I could have like a bunch of agents. But how many agents will I end up building, right? And there is no guarantee that I've covered all possible scenarios. And if I am building so many agents, is it really AI? Is there any intelligence there? Because now I'm just building these rigid pipelines under the hood, right? And there's no flexibility. Now, business leader can ask whatever they want. Will I have an agent to answer that question under the hood? So probably multi-agents is not the answer, right? But what if you could have a 100% accurate task-specific agent for any user query? And when I say any user query, I mean any user query. The user can ask anything that they want, give them a free-form text box. And what if there was an agent specifically designed to answer that query? And that allows us to reach 100% in accuracy if you have very task-specific agents under the hood. And that is also the idea behind PromptQL. So what PromptQL basically does is that you get a data agent which is 100% accurate for that specific user query. So instead of having these multiple agents under the hood that you need to orchestrate using natural language, you just have one LLM which understands the underlying data landscape and then writes its own agent on the fly, which will be 100% accurate for that specific task. And instead of confusing the LLM with multiple different data pipelines, we just give a single universal data access layer and just one way to access any kind of data, structured data, unstructured data, SAS data, API data. Just have one way of accessing any kind of data. And now I can have a highly accurate agent specifically on for that user query. So that allows us to surpass all of the problems that exist with the traditional in-context approaches, right? And get towards that 100% reliability that we've been talking about. So let's quickly look at what I'm talking about, and then we can take some questions. So, for example, I'll make this a little bigger. So I have this AI assistant which I built for like a typical financial firm, and they have an anti-money laundering use case where they want to answer a question like this: like, we have received intelligence about potential trade-based money laundering. Can you analyze the transaction patterns where there are frequent currency conversions between the sender and receiver accounts, especially where the payment currency differs from the received currency, and the transaction amounts don't align with the customer's expected behavior, right? So it's a complicated question with a lot of data that need to be fetched and processed. So what PromptQL does is looks at your question, looks at the underlying data landscape, and comes up with this query plan of how to approach this problem. It says that, okay, I will find the transactions which match our criteria, calculate the metrics like transaction frequency, transaction amounts compared to typical patterns, currency conversion patterns, and stuff like that. And then identify a high-risk transaction based on that. Make sense? Perfect. So now see what it's doing. It's implementing a task-specific agent under the hood. Oh, I ran into an issue. Okay, no worries. I'll adjust my approach to analyze the transaction patterns. Okay, it was using pandas, and I've not installed pandas in its runtime. And you see how it is implementing a very task-specific agent under the hood, which will do exactly that. That's exactly how humans operate. That's how your data analyst operates, right? So and let this continue and see what response we get. Okay, executed. It has identified 45 transactions with 13 different currency conversion patterns. Nice. Okay, and significantly deviates from the sender's typical pattern. Okay, so now I have a good analysis of some. This is the most suspicious transaction. I have different currency conversion patterns that I am seeing, and then there is no frequent sender receiver pairs. So there are no two specific accounts which are doing this a lot between each other. Okay, perfect. Let's look at another example, which is bigger, which is, let's say, again, some of you must have seen this example, but I wanted to ask this question all in one shot, where I want to see if I'm an enterprise software company, let's say, and I'm concerned that my highest value customer is about to leave us. So I want to find out that how are they feeling about their product, and I want to take some action, right? So I ask it that, hey, can you find the highest billed organization that we serve? The organization ID data is messed up, so use users' email domains to find the unicorns. Then for this org, fetch all support tickets across all of their users. So you need to find these in Zendesk. Then for each ticket thread, which means ticket details and comments on those tickets, summarize it. And then use these summaries to extract this organization's sentiment towards our product, right? So based on all of the tickets across all of the users, so there may be hundreds of tickets, can you extract this organization's sentiment towards our product? And if the sentiment is positive, issue $1,000 to their highest individually billed users, most used project. So we can issue a refund or credits to a specific project by a specific user of a specific organization. So, or if it's neutral, issue 2,500. If it's negative, issue 5,000. So now if I ask this question, let's see how PromptQL breaks this task down, right? And implements very task-specific agents under the hood. It's like, okay, first task is to find the highest billed organization based on email domains. So I'll get all the users and their invoice items, extract email domains from the user emails, and then group invoices for each domain, and then find out the highest bid. Perfect. Implements that agent, executes that agent. Now we know williams.com is our highest billed domain. Let's get all the support tickets. Oh, ran into an error. No worries. I'll figure out what the issue is and re-implement my agent. Okay, so again, looking at what's happening under the hood, you can see it's fetching all of the tickets for williams.com. Then it's saying that for each ticket, get its comments. And then once it's done with that, it's going to keep all of this data in a structured memory so that it does not hallucinate the next time it needs to use that information. So as you can see, these are all the tickets by williams.com. And then let's analyze the support tickets to understand the sentiment and key themes. So now it realizes that's a semantic task. I can't really do it in Python. So what I need to do is delegate that task to an LLM. So what I'm going to do is instruct an LLM that summarize the support ticket thread, focus on these criteria, be concise, and give me the information. And then finally, what it'll also say is that, hey, another LLM, based on all of these summaries, can you analyze the overall sentiment of williams.com towards our product and consider these factors, and then give me a structured response in this JSON format. And that's, you see how it broke the task down, understood that it's a semantic task, so it needs to ask an LLM to do it. And now it's batching it in 10 summaries, like 10 LLM calls at a time. So there are 68 support tickets, so this should take 7 turns to finish. But now I know this is like all deterministic. There is all of this, these ticket data is being handled properly. All of these summaries are being handled properly, and then I'm getting a very structured response. Okay, let's see where it ran into an issue. I see the error. I'll get the owner ID for the project table from the project table. Okay, perfect. And now it realized since the sentiment was positive, let me issue $1,000 in credit. And it's the data layer says that your AI is about to call this command. These are the parameters it's passing. Are you okay with that? And if I think that's okay, I'll just click on approve and let the data layer allow this command to work. And it will call the Stripe API under the hood and issue the refund. And as you can see, I get this nice report of the overall sentiment is positive. This is what's going well, what's not going well, and this is my reason behind that. And yeah, the refund was issued. See, this is how you can build highly accurate task-specific agents uh, on the fly without having to build multiple different domain-specific sub-agents under the hood, which need to orchestrate non-deterministically. Any questions? And Rob, back to you.
Awesome. Thank you. We do have a few questions that have come through. This is kind of a pair for the first one, so we'll see if Harsha can throw them on the stage for us. Yeah, so essentially what's being asked here is, how does Sasura make sure that 100% accuracy exists on the planning? And then have we identified cases where we have 100% accuracy on the planning, but then the agent implementation may mess up with the result and the synthesis that comes out from that?
Yeah, no, that's a completely fair question. So the way I like to answer this question is, how do you trust your data analyst is 100% accurate? Right? So you just have built some kind of trust with them, right? And now you know that if you ask a question, your data analyst will most likely be correct. But how did we build that trust? Based on their experience, based on the interviews we did with them, based on their past performance and stuff like that. Right? That's how you build trust. If you're saying, can you make your AI 100% deterministic? I'm like, can you make your human 100% deterministic? You can't, right? So, and AI are probabilistic models, just like humans are. So the way to think about accuracy is 2-3 ways. One is you test your AI out. With all of our customers, what we do is we ask them to give us a golden eval set of questions on which they want 100% accuracy, and we allow them to change these questions whenever they want. And it's basically an SLA of sorts where we tell them that if we do not get 100% accuracy on that, we probably won't sell our product to you. So and the customers do that. They give us a huge list of complicated questions, expected answers, and stuff like that, and test PromptQL on top of that. So that's how we evaluate accuracy. But the way we try to make the system very accurate is minimize the context it needs to handle, right? The LLMs need to handle a lot of context when it really comes to enterprise data questions, right? So right now, here PromptQL LLMs don't really have to handle a lot of data itself. They just need to handle metadata, right? And then they need to come up with this kind of an approach. Then the accuracy is in the system, not in a one specific LLM response. We do not say that every single LLM response will be accurate, right? No, it's not. It errored out in front of you once. So of course, it won't be 100% accurate all the time. But it understands if it runs into an error, fix itself. Second, it tells you exactly what it's going to do. So you as the user have complete control. You can stop the execution, you can edit the query plans, and you can ensure that you are reaching 100% accuracy. If you're technical, look at the Python code. If you're not technical, just look at the query plan. But you are equally responsible as this person, as the consumer, to ensure that the AI is on the right track.
So there's a couple other questions that come up along those same lines that are kind of focused on the human in the loop. So Harsha, if you'll throw up the first one that we had there from Abe, I think, or the next one after that, Harsha, because that was kind of related to what we just had there. But a couple of questions have come through about the human in the loop. And you just kind of explained, right, that you have the ability to edit the query plane itself, and that can change the execution that comes from there. I think some people have questions, though, around, as an example, like the mutations that exist or the commands that come through. So like Stripe as an example, how are we triggering, or how do we know like that a human needs to be involved in the execution?
Oh, that's a great question. So, okay, any database write operation, any mutation that happens, a human will be involved. I mean, you can turn off that flag if you want, but a human will be involved and it's not determined by the LLM. It's determined by the underlying the universal data access layer. So the universal data access layer, if it's connected to a database and there are write operations happening, it will flag it as a write operation and ask the PromptQL system that, hey, can you get users input on that? Or a mutation is being called, or like a post API is being called, right, under the hood. But so that's one. The second place where the human needs to be involved is when the LLM realizes that it does not have enough context. Like if I would have asked this question, like my internal customer support agent, if I ask it that, hey, what are the highest selling movies in the last 20 years based on the specific data set? Like, what are you talking about? I don't even have that data under the hood. So can you please ask me something else? So that's when the LLM determines when the human is needs to be in the loop.
Awesome.